we are asking ourselves what exactly occurs in glycolysis. I'm still your teacher Osbert Nwarinda. Now, in glycolysis, as we know, as we have already seen the definition and so on, we are going to have our glucose. Everything begins from glucose. Now, allow me first remove this so that I can have enough space. So, everything is going to begin from glucose. Remember, this glucose is a 6-carbon molecule. Remember, we are in the cytoplasm. So we are going to have our glucose. This glucose will undergo a reaction, and this reaction we call it phosphorylation. This reaction we are calling it phosphorylation. We are calling it phosphorylation. From the way you hear the word phosphorylation, that means we are adding a phosphate. What enables us to add phosphate? What is going to help us to add a phosphate is ATP. And therefore, we are going to have our glucose and having ATP added to it. Now, what we are saying here is that when this ATP reacts with this glucose, what happens is that the ATP adds a phosphate to the glucose. And once ATP adds a phosphate to the glucose, that means the ATP would have lost a phosphate. And therefore, after it has lost a phosphate, it means this glucose, this ATP for it will remain as ADP. And then the phosphate is what is going to be added to the what? To the glucose. And once it is added to the glucose, then we shall form a phosphorylated glucose, and that glucose that is phosphorylated we are going to form is what we are calling glucose. We are going to be calling it glucose 6-phosphate. Glucose 6 what? Phosphate. Now, 6 is just the carbon atom where phosphate is attached. Glucose is the glucose we had, which has gotten a phosphate. Now, we are saying we get glucose, we phosphorylate it, or the glucose undergoes phosphorylation to form glucose 6-phosphate. And what enables the phosphorylation reaction is the ATP. Now, I want to first pause there a bit. Do you know why? Because somebody here is looking at me with a different eye. And what's that different eye? He's saying, hey teacher, we are in respiration, for sure. We are in respiration, and this respiration, our major aim, we are supposed to manufacture energy, which is going to be kept in our body, as in form of ATP. Now, teacher, how come? Even on the first step, you are instead of producing ATP, we are using ATP. Are you asking that question to yourself? Respiration is to produce ATP. Now, on the first step we are first studying, we are saying ATP is used in the process of manufacturing ATP. Teacher, how is that one possible? If you have been asking yourself that question, then you are in class. Yeah, it's a very good thing to ask yourself that question. But the answer is very simple. What's the answer? The answer is very simple in a way that if you want to start a business, if there's a business you want to start, what's the major aim as to how you're starting that business? The reason as to you're starting that business, I know you want to tell me that it is to make profits, but the major importance is to make money. Of course, you make money in the form of profits. But the question is, do you want to make money in this business? Don't you put in money? Don't you need money at the start? You need money at the start in form of capital. So just like the way, when you want to start a business, you need capital. Your major aim of starting a business is to make money. But for you to make that money, you need money at the start, which is in form of capital. Then you're going to use that capital to make more money, which is going to be called profit. That's the same science that is happening in our body. Very interesting. So, yes, we want to manufacture ATP. We want to manufacture energy, which is going to be stored in form of ATP. However, for us to be able to do that, we need some energy, we need some capital, we need some investment, we need to invest something. And that this ATP is now acting like an investment, is like capital we are incurring so that we can manufacture more energy. I hope we are together. Yeah, so let's go back here. So we are saying glucose undergoes phosphorylation. A phosphate is added onto it. Who helps us to add a phosphate? We are saying it is ATP. And once ATP releases the phosphate to this glucose, form glucose 6-phosphate, so it becomes ADP. Now, this reaction also has got importances. And what's the importance? This first step here is so important because of the following reasons. One, it is very important because it makes glucose activated. This first process here, when glucose gets a phosphate, it makes the glucose become, and the glucose molecule becomes activated. It becomes now activated to start participating in the reaction. Number two, we are saying another importance of this first step. Another importance of this first step is it is important in it prevents glucose from escaping from the cell. That's another importance. Why? When a phosphate is added to glucose, it makes already glucose is a polar molecule, and you know that polar molecules usually have issues with passing through the cell membrane. Now, if this glucose has been able to pass through the cell membrane and it comes inside the cell, now we are saying once this glucose has reached the cytoplasm and it has gotten a phosphate, it makes this glucose more polar in such a way that it now becomes very more difficult for it to again pass or to escape through the non-polar cell membrane to go back to escape away from the cell. So we are saying glucose having a phosphate added onto it prevents that glucose from escaping out of the cell, and therefore it makes the glucose to remain within the cytoplasm so it can undergo further reactions to produce energy that we want. Clear? We are going slowly. Now, we are saying after we have got the glucose 6-phosphate, we don't stop there. And maybe as we progress, all the reactions that usually occur are usually catalyzed by enzymes. However, these enzymes, I would advise you for the advanced level, we may not go into those too much details. What you're going to do is you're going to keep using, where possible, you're going to use general names. For example, enzymes which usually catalyze addition of phosphates, usually give them a general name. And those general names usually call them kinases. Enzymes which catalyze addition of phosphates are usually called kinases. Where you know the specific name, please give the specific name. Where you don't know the specific name, use a general name. Where you don't know the name, leave the name. Yeah, if you know the name, leave the name. Where you know the specific name, well and good, give it. Where you know a general name, use the general name. All in all, we move. So we are saying the enzymes which catalyze reaction which involve phosphorylation, we refer to them as kinases. For example, for this one here, we can also call it exokinase. This enzyme, this reaction here is catalyzed by an enzyme which we can refer to as exokinase. That's our enzyme which catalyzes that reaction. Are we together? Now we are saying after we have got glucose 6-phosphate, we don't stop there. Now this glucose phosphate that has been activated undergoes isomerism. It isomerizes. So it means the next step here that is going to happen, the next thing that is going to happen here is a very short step, is another important step, and that step we are calling it isomerism. So once glucose isomerizes, it forms fructose. It forms fructose 6-phosphate. I hope you know, or if you didn't know, maybe you have now known. Glucose and fructose are isomers. What do we mean? When you look at the structure of glucose and the structure of fructose, if you go to the biochemistry, their structures are almost the same. they just differ. The structures just differ in how carbon atoms are organized. But when you go into molecular formula, the molecular formula of glucose and fructose are actually the same. They have the same molecular formula, but when you go into the structural organization, the structural organization is what makes them different. So fructose is an isomer of glucose. So when glucose 6-phosphate turns into fructose 6-phosphate, we just simply say that the glucose 6-phosphate would have undergone isomerism. It would have isomerized. You get? So what happens here? The step that is happening here is isomerism. So glucose 6-phosphate undergoes isomerism, and it forms the fructose 6-phosphate. The enzymes which catalyze, I told that the enzymes which catalyze the addition of phosphates, phosphates, we call them kinases. You can just simply keep on putting kinase enzyme. Enzymes which catalyze isomer reactions which involve isomerism, we usually refer to them as what? Isomerases. So here we have an enzyme which is called an isomerase enzyme. Isomerase enzyme. Now, I want to ask you, do you know that exact enzyme do you know the exact name of this isomerase enzyme? Because I told you this isomerase is just a general name. So the assignment I'm giving you is to look out for you, in case you're interested. Look out for the exact name of that isomerase enzyme if you're interested. If you're not interested, you can leave it. You can also go with that it is called isomerase. Though we have very many isomerase enzymes, because it's a general term for all the enzymes that catalyze reaction that involve isomerism. Now, when we have got glucose 6-phosphate, what happens is we are saying this glucose 6-phosphate does not stop there. It also undergoes another reaction, and this reaction is further phosphorylation. So we are saying this fructose 6-phosphate undergoes another stage which we are calling further phosphorylation. And when it undergoes further phosphorylation, what happens? We are saying this fructose 6-phosphate now will form a molecule which is called fructose 1,6-bisphosphate. Some people call it fructose 1,6-diphosphate. Some people call it fructose 1,6-biphosphate. They are all correct. Biphosphate, diphosphate, bisphosphate, they are the same. So we are now saying, whenever we talk about phosphorylation, we are saying we have something that enables us. There is a molecule which is always in the cell that helps us to phosphorylate, and that is none other than what we already have here, which is our ATP. So once more, we are going to utilize the ATP, which we are trying to make. Here we are going to utilize, we are going to put in more effort, more capital. Here we are still adding more capital, we are still investing so that we can get more profits. So we are going to put in more ATP, which of course we want to make, but we are now here investing. So we are going to have again this phosphorylation, just like the way it happened here. We are going to phosphorate by using ATP. So it is this ATP which is going to again help us. This ATP which is going to again help us to add a phosphate to this fructose 6. And now when fructose 6 gets another phosphate, that's why we are having now this bi coming in. This bi is that's how it is coming in that way. Why? Because we are saying we are having fructose 6-phosphate, we are adding another phosphate from ATP, and therefore now we get fructose 1,6. Now the 1,6, of course, when you go into the nomenclature and so on, this is just in nomenclature. The biochemistry may not go into that detail. Yeah, so we are saying now ATP donates a phosphate, and then for ATP it becomes ADP. The phosphate has come in, it has now made us turn fructose 6-phosphate into fructose 1,6-bisphosphate. That means one phosphate is attached to carbon atom number 1, another phosphate is attached to carbon atom number 6. I think if you go into the biochemistry, that's how it comes into the 1,6-bisphosphate. Now, what do you know about this molecule here? This molecule has got something very special, has got some, of course, before I go to this, what is the enzyme? Is this one catalyzed by an enzyme? Yes. What is the enzyme? Of course, the enzyme is also a kinase enzyme. The enzyme is also kinase. But now, if we know the specific name, you give us the specific name. For example, here, the name is what? Phosphofructo. We have what you call phosphor. This is called phosphofructo. What? Kinase enzyme. That's the enzyme which catalyzes that reaction. You see, we are still having the kinase there because we are phosphorylating. So, phosphofructokinase. You see this glucose. Glucose is a 6-carbon sugar. So, this hexose can come from the word hexose. Hexose sugars are sugars which have 6 carbons. So, when you say hexokinase, this glucose is a hexose sugar. I'm just trying to give you some hints of why maybe we are getting these names. Now, when you come here, for example, we are saying phosphofructokinase, we are adding a phosphate onto fructose 6-phosphate. So this is phosphofructo. This fructo is fructose. Phosphor is phosphate. So we are phosphorylating fructose 6-phosphate. So we just modify that word and we get our phosphofructokinase enzyme. Just in case somebody is interested in knowing how those enzymes are coming about. Now, fructose 6-phosphate has some unique features. What are those unique features? What is the unique characteristic about fructose 1,6-bisphosphate? Something unique about that molecule is that it is what? This molecule is known to be unstable. And the molecules which are unstable always have something unique. Maybe before I can continue, we have told you that this one here was glucose 6-phosphate. It was glucose, and glucose was having 6 carbons. When you come to glucose 6-phosphate, this also has how many carbons? The carbons here for glucose 6-phosphate are also what? They are also 6, because we have not changed anything. We have just added a phosphate. And then here, from fructose to 6-phosphate, from glucose 6-phosphate to fructose 6-phosphate, we have not added any carbon. We have not removed any carbon. We have just undergone isomerism. You get? So it means this one is also having 6 carbons. What about this one here? We have just added a phosphate. We have not added any carbon. I just added a phosphate. That means this also is having what? 6 carbons. You get? So because of that, we are saying that this molecule we have here is unstable. And whenever molecules are unstable, what happens? They usually undergo splitting. Those molecules which are unstable undergo split. They usually split. Whenever they split, they form molecules which should be having equal molecules, which should be having the same number of carbon atoms. So it means if this one is fructose 1,6-bisphosphate and is having 6 carbons, when it splits, it's going to split into 2 molecules. And these 2 molecules should all be having 3 carbons to make up the what? The 6. So what is going to happen here is, because this is unstable, what is going to happen is this molecule will undergo splitting. This molecule will undergo splitting. So the process which is occurring here is what we are calling splitting. You can call it breakdown. It will split. And when it splits, it will form 2 molecules. And these 2 molecules are all having 3 carbons. So we shall have, and these 2 molecules are, one of these molecules is, one of these molecules is this one here. One of these molecules that is formed is called PGAL. PGAL, or sometimes we call it GALP. Some books call it TP. Either way, you just pick the one which is you pick. You can pick anything that is any of those that is easy for you. PGAL, GALP, or TP. What are these? This is phosphoglyceraldehyde. 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 Phosphoglyceraldehyde, or we can also call it glyceraldehyde 3-phosphate. You can also call it glyceraldehyde 3-phosphate. Or some books call it a triose phosphate. Triose phosphate. This is triose phosphate. This is glyceraldehyde. This girl is glyceraldehyde. G is glycerol, kind of the glycerol. Then this is L is aldehyde. So this is glyceraldehyde phosphate, but usually put a 3 glyceraldehyde phosphate. This is phosphoglyceride. So it means in this case we're just putting P first. Here P we are putting it last. So you can choose any that is making life easier for you. For example, you can choose to pick maybe PGAL. Now this PGAL, we are saying this PGAL is having how many carbon atoms? Is having 3. This is 3 carbon molecule. Now likewise, we are also going to form another molecule here, and this molecule is also called the DHAP. DHAP. This molecule is formed here is called DHAP. 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 Now what is DHAP? DHAP is what? This DHAP is also 3 carbon. It is also a 3 carbon molecule. It's also made up of 3 carbons. Remember I told you if this is 6 carbon, when it splits into molecules which are having 2 molecules which are having 3 carbons each. Now this DHAP is what? DHAP is a short form for dihydroxy. This is dihydroxy acetone phosphate. Dihydroxyacetone phosphate. This one was phosphoglyceraldehyde. So these formula short forms are allowed. You can write them even in an exam. You can even write those formulas. This PGAL, for example, is allowed. Yeah. So we are saying DHAP. This is what is formed. However, this DHAP, after it has been formed, it quickly undergoes isomerism. And when it undergoes isomerism, after it has undergone isomerism, it will form PGAL. It will form PGAL, what we have also called the GALP, what we have also called the TP. We have also called TP, just like what we had here. So this DHAP here, this DHAP here, we are saying once it is formed, this quickly it quickly isomerizes, and when it isomerizes, so here this DHAP and also undergoes isomerism. It also undergoes isomerism to form this. Now, after it has undergoes, now this thing that is formed is also just having 3 carbons. So it means DHAP and PGAL, they are all having the same molecular formula. What differs is the arrangement of atoms within their structures. Those are isomers. Have the same molecular formula but different arrangement of atoms within their structures. That's what happens with these two. Now we are saying, if I can continue, don't we have enzymes? Don't we have an enzyme here? Yes, we have an enzyme here. And what's that enzyme? The enzyme which catalyzes the splitting. The enzyme which catalyzes the splitting of fructose 1,6-bisphosphate into these two is called aldolase. That enzyme is called aldolase. That's the name of the enzyme. Okay, likewise here, the enzyme which catalyzes this one, like we have been saying, of course, this will still be isohati. This will be isomerase enzyme. So after we have formed these two, now we are saying each of these two, of course, each of these two now undergoes a series of reactions. Each of these undergoes a series of reactions, and these series of reactions, each of these molecules, for example, if I begin from here, for example, this PGAL will undergo a series of reactions, and these series of reactions will result into formation of what we call our final product, which is called Pyruvate. Likewise, even this one here, this PGAL here, which was also carbon, will also undergo a series of reaction, and those series of reaction will result into it forming what we call Pyruvate. Remember, I've told that this pyruvate is from the start, from our definition of glycolysis, I told that pyruvate is having 3 carbons. So these are 3 carbons here. This is a 3 carbon molecule. This is a 3 carbon molecule. 3 carbon molecules, 3 carbon compound. Now we are asking ourselves, in these series of reactions which are taking place here, what exactly happens? Of course, if in case you are more interested, you can go and look out for these series of reactions exactly, and you go one by one, on a condition that you'll be able to recall all of them. But if you cannot be able to recall all of them, we are saying we just summarize like that. We don't go into all those other details. For those ones who want to do biology and take it at higher level, of course, those series of those steps of those other series of reactions, you study about them. But for now, we are just summarizing them in that format. So in this series of reactions, what exactly occurs? What occurs here, what occurs in this series of reactions are 2 major processes. And these 2 major processes, one of the processes that occurs in this is called dehydrogenation. It's called dehydrogenation. And then the other one is called dephosphorylation. What am I saying? I am saying in this series of reactions, there are many reactions take place there, but these reactions, one of the things that are involved there, one is dehydrogenation, and the other one is called dephosphorylation. Those are the key processes which take place in this series of reactions here. We have dehydrogenation and dephosphorylation. So the question again is, what enables us to carry out dephosphorylation? What enables us to carry out dehydrogenation? Now, let me begin with dephosphorylation. Here, dephosphorylation is the opposite. Dephosphorylation is the opposite of phosphorylation. So if in phosphorylation, ATP was providing a PI, was providing a phosphate, and it was turning into ADP. Now, at this point, this is the point when now ADP will come and say, here I am, I need back what I gave you. Get? So now, in this case, in dephosphorylation, we are just doing the reverse of phosphorylation. Phosphorylation, we are doing the opposite under dephosphorylation. So what happens now here is, at this point now, the ATP, the ADP, this ADP, the ADP which had been formed, it is there. It is there in the cytoplasm. We now come and say, okay, I gave you a phosphate to help you progress, but now it's time for you to give me back my phosphate. So now the ADP will now come into this reaction, which is involving PGAR, and will pick out its PI. It will come and pick out its phosphate, and it will come back. It will again turn back at what? It will turn back to ATP. Yeah. So we are saying in this series of reaction, what happens is that the ADP will now come and say, give me what I had given you. It was used me as an investment, used me as a capital. Now, can I see back my capital? Where is the capital? If after the business has gone further, you have done the business is now doing well, the capital must be there, must come back. But that capital should come back with even profits. You get what I'm saying? Yeah. Now, at first you put the capital of 2 million, but now at the end of the day, you should have the 2 million, what was the capital, plus the profits that you have made. So this ATP here we had 2 ATPs being used as what? As capital. Now it's time for us to get the profits. So now the ADP comes and says, hello, give me my phosphate back. So the ADP now picks the phosphate and it forms back at what? It now again becomes ATP. Please mind about my arrows. Look at how my arrows are. I'm having ADP come into this reaction. In this reaction, it picks the PI, it picks the inorganic phosphate, and then it becomes ATP. Here, look at this arrow. This arrow, it was saying ATP was coming here and it was turning into ADP. That means this ATP has donated a phosphate. That's why it has now come when it is less. But here it has come when it is less. It has picked the phosphate, it has become more. Hope that is clear. Okay, now we are saying this time when it comes to this point here, during during this series of reactions, we are saying this reaction where ADP is picking a phosphate from ATP occurs twice. During this series of reaction, this step here where ADP is picking a phosphate from ATP occurs twice, and therefore that's why I will come here and I put 2. We have 2. It means that during these reactions we have 2 ADP come inside this reaction, pick 2 phosphates, and when they pick the 2 phosphates, it means we end up having 2 ATP being formed. Likewise, even during this on this side here, or from this other pigar, when these reactions are happening, we shall have this step occurring twice. That means we shall have 2 ADP molecules come into this reaction, into this series of reactions, pick 2 phosphates, and therefore forming 2 ATP molecules. Are we together? Yeah, I think we are together. So it means in this case, how much ATP did we incur at the start? We incurred 1 ATP, we incurred 2 ATPs here. How much ATP are we getting now? From one of the pigar to form pyruvate, we are getting 2 ATPs. From another, remember these ones were 2. When this one split, they were 2. Now from another pigar, what are we getting? From another pigar, we are getting also 2 ATP. That means how many ATPs are we getting? It means now at the end of glycolysis, we are having 4 ATP. We incurred 2, we have now gotten 4. That means you have gotten back our capital of 2. We have again gotten a profit of 2. So it means in glycolysis, we will produce a net ATP of what? Of 2. The gross ATP we produce is what? Is 4. Then to get the net, we get the gross, the overall total. The overall total is there are 2 from here, 2 from here. Those are 4. Then to get the net, we subtract what we incurred. We incurred 2. So it means glycolysis alone, if you have one glucose molecule, just one glucose molecule, from glycolysis we're able to get 2 ATPs being formed in our cell. Isn't that one very interesting? That's very interesting. Now, remember we say that is for the phosphorylation. But I say there's also the what? The hydrogenation will remove, the hydrogen means removal of hydrogen. And therefore, what enables us to remove hydrogen is a molecule here. And this molecule is known as NAD. NAD. We have a molecule which is known as NAD. NAD. Nicotinamide, adenine dinucleotide. Nicotinamide, adenine dinucleotide. That's the NAD in food. These are we call them hydrogen carriers. These are molecules. These are nucleotides which are present within the. Here the name. These are nucleotides which are present within the cell that enable to carry hydrogen from one reaction to another. That one of them is NAD. As we progress, we're going to find another one which is called FAD, and so on and so forth. So in this case, we are going to use NAD. So what happens is that during these reactions, as these reactions are taking place, we are going to have our NAD. We are going to have NAD. This NAD comes when it is in this form. When that NAD is not having hydrogen, it is oxidized. We call it oxidized NAD. It is not having. Remember, oxidation means what? Means receiving of oxygen and then loss of hydrogen or loss of electrons. So in oxidation, if you don't have hydrogen, we say you have what? You have been oxidized. When you get hydrogen, we say you have been reduced. 1G. Yeah, when you get the hydrogen, we say you have been reduced. When you don't have hydrogen, we say you are oxidized. So this one we call it oxidized NAD. So NAD comes in when it is oxidized. So when this NAD comes in this reaction, it is able to pick hydrogen atoms. Okay, it is able to pick protons. It picks hydrogen, but this hydrogen it picks them in form of protons. It is able to pick protons, and once it picks the protons, what happens to it? This NAD becomes NADH. Why? It has picked the hydrogen and it becomes NADH then plus H plus. Yeah, that's how it becomes. It becomes NADH plus H. Now somebody might say, teacher, now why putting why don't you just say NADH? Yeah, I can still say NADH, but we are saying the proper way is you say NADH plus H plus hydrogen ions. Teacher, why? Yeah, I want to know why. I'm going to explain to you why. Likewise, here in this side, we shall have our NAD. We shall have our NAD. This NAD comes when it is oxidized. When it comes into this reaction, these are many reactions which are taking place. But in these reactions, hydrogen ions are given out. What we also call protons, they are given out. So those hydrogen ions are taken up by this carrier. And once they are picked up, now this one moves from being oxidized, becomes reduced. So the reduced form is called what? Is called NADH. I've said you can write NADH and you leave, but I'm saying the proper way is supposed to be NADH plus H ions here. That's the proper way. Teacher, before you leave, explain to us why are you saying NADH plus H? Why you don't just say NADH and you leave? Okay, let me explain. But it's just a by the way. It's not very important. It's just a by the way. So don't be there and then you start to explain this. It's not very important. But let me explain just for your demand. Now, why we are saying NAD? The reality, what exactly happens here is, I'm just writing it here. I'm going to rub it. Exactly what happens here. And let me just use this small space here. What exactly happens? Why I'm putting NADH plus hydrogen is, the reality is, this NAD, you see, this NAD plus, you see, when it comes into these reactions, it will find there hydrogen ions, which are 2, and also find there electrons. And with these together, that's how they will end up forming the what? That's how they will end up forming the NADH plus H. That is now when you go into the chemistry. But the question is how? We haven't understood. Still explain how. The reality is that ideally during this reaction, this is what happens. These two first react together. For example, during reaction we have this reaction first take place, and this reaction we shall first pick out one proton. One proton, that's the first proton. And this is the one proton here. This proton first combines with the 2 electrons. When it combines with the 2 electrons, of course, now what will happen is this electron, this negative charge, will first cancel one charge. One electron will come with the one electron will first cancel the one negative will cancel one positive, so the electron will first cancel with the positive charge here, and then it means now what will happen is, because one positive has cancelled, this negative electron has cancelled with this positive, now you remain with the negative here. You remember this negative here, you have two negative charges, here you have one positive charge. So what will happen is that this negative charge, this first of the 2 negative charges, we shall pick out one and it cancels with that positive. So if one negative charge has crossed with this positive, that means this positive has gone, and here we have remained with one negative. So when you get one, if you get this, and then you combine it with the electron here, one electron has cancelled with this positive. So when you get now this one plus this, what will you get? You will get what we call hydride ion. Are you seeing? Now remember, this was what we have used there. We used one hydrogen. Remember, these hydrogens were 2. So when you get this one, when you get this hydride, now we are saying that hydride here, this hydride is the one which is going to come and combine with NAD. Remember, this NAD is a plus. So now this negative will first cross with this positive, and once the negative crosses with the positive, so you remain with hydrogen atom with NAD. So when now the negative has crossed with this positive, so we shall remain with NAD combining with H, and that's how you end up having the NADH. So remember, now we have formed the NADH. That's how the NADH is formed. But remember, here we had picked one hydrogen. We picked one hydrogen ion. We didn't pick another, so it means there's the one more hydrogen ion which is just remaining here. Remember, we had picked only one. There is one hydrogen ion which is still remaining there. So that hydrogen ion is what you come and add. Is this one we are adding here? This is the hydrogen ion we are adding there, because here we had used one hydrogen ion to combine with 2 electrons to form hydride. And then hydride came and combined with NAD plus to form NADH. So this hydrogen ion is still there. So this is what we are putting here. So, but this is really, you can ignore this part. You can ignore it. This part you can ignore it. I was just explaining for those ones who may want more other details, but you can ignore it. Can just take it like that. So I can say NAD plus becomes NADH, and I stop it at that. But we are saying the proper way is when you do it like that. So from here, you see, of course, the enzymes which catalyze these ones, we shall find there the enzymes we call like dehydrogenases, because we have dehydrogenation and other enzymes. But I've said, if you're sure of the enzymes, mention them. If you're not sure, ignore them. So here we have many enzymes which are involved that we cannot mention one by one. So here we have got our glucose being broken down. We are talking about glycolysis. Our glucose has been broken down into 2 molecules, and those 2 molecules are pyruvates, and each of these pyruvates is having 3 carbons. And as that one was happening, we have seen 2 ATPs. We have got a net profit of 2 ATP being formed. Please, you don't need to miss out what is coming next. Thank you very much. I hope you have learned something.